You know what's interesting? It's not always the loudest explosion or the biggest gun that changes a war. Sometimes it's something much simpler, something you could drive right past without a second glance. And that's exactly what happened when a group of German mechanics got their hands on an abandoned American vehicle in the North African desert. What they discovered in the next few hours? Well, it shook everything they thought they knew about their own superiority. Before we dive into this, grab yourself a coffee, settle back into your chair, because this story, it's going to take us on a journey that changed not just a war, but an entire way of thinking about how things should be built. And make sure you hit that like button and subscribe, because stories like this, they deserve to be remembered. All right, let's get into it. November 1942, the Western Desert, sand, heat, and wreckage as far as the eye could see. In the middle of this desolation sat a vehicle, abandoned by its crew when their position became impossible to hold. Standard procedure for the Wehrmacht was simple: destroy it or leave it behind. But the commanding officer of this particular reconnaissance unit, he had different ideas. He wanted to know what made this American machine tick. So he called for his best mechanic and said, "I want to know if we can use this thing. Get me answers." What happened next, over the course of maybe 30 minutes of inspection, would challenge decades of German engineering confidence. The mechanics approached the vehicle cautiously at first. It was painted in that distinctive olive drab, dusty from the desert, but otherwise intact. On the dashboard, a small placard read, "Willys MB." The Americans, they called it a Jeep. Strange name, really. But the name didn't matter. What mattered was what they found when they opened the hood. The engine compartment. It was immaculate. Not in the sense of being pristine, no, but in its design. Everything was laid out for one purpose: rapid maintenance by anyone with basic knowledge. The wires were color-coded. Components were clearly labeled. You could reach every part without needing specialized tools. The senior mechanic, a man who had spent 2 decades servicing German military vehicles, stood there looking at this engine and realized he had never seen anything quite like this. The thoughtfulness of it, the simplicity. Every bolt was standard. Every component appeared identical to every other Jeep they would eventually encounter. This wasn't accident. This was design. Intentional design for mass production and easy replacement. The engine itself, they called it the Go Devil. Displaced about 134 cubic inches, produced roughly 60 horsepower at 4,000 RPM. Now, by German standards, that wasn't impressive. German engineers could have, and did, build more powerful engines. But the philosophy behind this engine, that was revolutionary. This engine wasn't built to be perfect. It was built to be simple, reliable, and above all, producible. A mechanic with minimal training could service this engine with basic tools. No specialty wrenches, no complex procedures requiring factory-trained technicians. The Americans had designed this vehicle expecting that farm boys and factory workers, young men who maybe had never seen an engine before, would need to maintain it under combat conditions. That assumption, that design choice, it revealed something profound about American thinking. By November 1942, the contrast between American and German military vehicle philosophy had become stark. America would go on to produce over 640,000 Jeeps during the war. Germany managed just over 50,000 Kübelwagons, their equivalent vehicle. Now pause for a moment and think about that ratio. For every German light vehicle, America produced nearly 13 to 1. That disparity, it represented something deeper than just numbers. It represented 2 entirely different approaches to warfare itself. The Jeep embodied American manufacturing thinking at its finest: standardized, simplified, designed for mass production by semi-skilled workers using interchangeable parts. It wasn't elegant in the way German engineers understood elegance, but it was effective in ways that mattered more. The officers approached as the mechanics continued their inspection. One of them asked, "Well, can we use it?" The senior mechanic looked up, and you could see he was choosing his words carefully. He said, "This vehicle is remarkable. It's designed by someone who understands field conditions." One of the officers frowned at that. "German engineering is the finest in the world," he said. The mechanic, he didn't argue. He simply gestured to the four-wheel drive system. He said, "Look at this transfer case. A single lever engages four-wheel drive. One lever. Our Kuba wagons, they require multiple operations, and most of them don't even have four-wheel drive at all." Now, the Kuba wagon, it was an excellent machine in many respects. Ferdinand Porsche had designed it with typical German attention to detail. It was lighter than the Jeep, used less fuel, and its air-cooled engine eliminated the vulnerability of radiators to enemy fire. These were real advantages, but it had one critical weakness. It was rear-wheel drive only. In the soft sand of North Africa, in the mountains of Italy, in the mud of Russia, that limitation proved devastating. The Jeep, by contrast, could power all four wheels whenever needed. The system was so simple that an uneducated soldier could master it in minutes. The mechanics continued their inspection. The suspension used simple leaf springs, crude compared to the Kugelwagen's sophisticated torsion bars, but infinitely easier to repair in the field. The electrical system was basic but robust. The fuel system could run on almost any grade of gasoline without modification. But what troubled them most was the weight distribution. The Jeep weighed approximately 2,450 pounds compared to the Kugelwagen's 1,540, a difference of 910 pounds. German engineers would have considered this excess weight a flaw, something that reduced performance and increased fuel consumption. But these mechanics, examining this vehicle in the desert, they recognized the method behind what appeared to be madness. That extra weight translated to durability. The frame was overbuilt, designed to handle punishment that would destroy lighter vehicles. The Americans had decided that reliability under abuse mattered more than optimal efficiency. They had built a vehicle expecting it to be misused, overloaded, subjected to conditions no engineer would approve of, and they engineered it to survive anyway. This wasn't the American incompetence that Wehrmacht training films had promised. This was engineering focused on reality rather than theory. The unit brought the Jeep back to their forward position. Over the next 3 days, mechanics conducted exhaustive tests. They drove it through soft sand where Kugelwagens struggled. They loaded it beyond its rated capacity. They subjected it to abuse that would have crippled most vehicles. The Jeep absorbed everything. In soft terrain, where rear-wheel drive vehicles required careful driving and often became stuck, the Jeep simply powered through. The low-range gearing allowed it to crawl over obstacles at walking speed, something the Kugelwagen's gearing couldn't match, despite its reduction hubs. Word spread through the Africa Corps. The Americans had a vehicle that outperformed the Wehrmacht's equivalent in almost every meaningful way. Officers and mechanics from other units came to examine it. The reactions followed a predictable pattern. Initial skepticism, followed by grudging respect, then dismay as the implications became clear. One supply officer, a man who'd worked in German automotive plants before the war, spent an afternoon studying the vehicle. His assessment was blunt. He said, "This represents a fundamental difference in approach. We build vehicles to achieve engineering perfection. The Americans build them to be manufactured. In total war, that matters more." He explained to the assembled officers and NCOs what that difference meant. He pointed to the engine block. "Look at this," he said. "It's cast, not machined to fine tolerances. The Americans sacrifice a small amount of performance for massive gains in production speed. They can train a semi-skilled worker to assemble one of these engines in a fraction of the time it takes to build a German engine. Now multiply that across every component." He pointed to the stamped metal body panels. These panels, they're crude compared to our vehicles, but they can be produced by the thousands in factories that previously made household appliances. The Americans, they've mobilized their entire economy. Every refrigerator factory, every washing machine plant, every commercial vehicle manufacturer, all converted to military production. We cannot match this capacity. The officers fell silent. He had articulated what many had begun to suspect. Germany's philosophy, focused on quality and precision, made sense in peacetime. But in total war, the American approach of adequate products delivered quickly was proving devastatingly effective. One mechanic spent that evening writing a detailed technical report. He documented every aspect of the Jeep's design, noting both its strengths and weaknesses. The report made its way up the chain of command, one of thousands of such documents produced by German technical intelligence services. Similar reports were flooding into Wehrmacht headquarters from every front. German mechanics and engineers were encountering American vehicles and equipment with increasing frequency, and the assessments were uniformly troubling. The Americans were outproducing Germany by ratios that seemed impossible. In late 1942, Wehrmacht intelligence commissioned a study of Allied vehicle production. The results confirmed their worst fears. American factories were producing military vehicles at a rate of thousands per day. Ford's Willow Run plant alone was completing a B-24 Liberator bomber every 63 minutes at peak production. American shipyards were launching Liberty ships faster than Germany could sink them. The statistics revealed a sobering truth. America's 1942 military vehicle production exceeded the total production of Germany, Italy, and Japan combined, and production was still ramping up. The captured Jeep became something of a celebrity in its unit. Soldiers competed for the chance to drive it. Officers used it for forward reconnaissance, trusting its reliability more than their own vehicles. When parts wore out, replacement components were scavenged from other captured Jeeps with disconcerting ease. Everything was interchangeable. Everything. By early 1943, the Afrika Korps had captured dozens of Jeeps. Wehrmacht mechanics formed informal networks, sharing maintenance knowledge and scrounged parts. A black market emerged for captured American vehicles and equipment. A working Jeep could command prices far exceeding its theoretical value because everyone recognized its superiority for desert warfare. Then came May 13, 1943. The Afrika Korps surrendered in Tunisia. Approximately 250,000 German and Italian soldiers became prisoners. Their war was over, but their education in American manufacturing capacity was just beginning. The contrast between German and American capabilities became impossible to ignore during the journey to captivity. American trucks transported prisoners in quantities that would have required horse-drawn wagons in the Wehrmacht. Liberty ships, typically built in just 5 to 6 weeks at peak production compared to 8 months initially, carried thousands across the Atlantic. Every aspect of the logistical operation demonstrated organizational capacity that dwarfed anything Germany had achieved. At the prisoner processing center in Oran, Algeria, captured mechanics watched American motor pool sergeants service a fleet of vehicles with casual efficiency that would have been impossible in the Wehrmacht. The motor pool contained dozens of jeeps, trucks, and command cars. Young American soldiers, many barely out of their teens, performed maintenance with speed and confidence. Tools were abundant and readily available. Parts were delivered without requisition delays. Every vehicle used the same basic components, allowing mechanics to service any vehicle without specialized knowledge. One American sergeant, who spoke passable German, noticed a captured mechanic watching. "You a mechanic?" he asked. The German nodded. "I was. Afrika Korps, vehicle maintenance." The sergeant grinned. "Well, no war for you now, but I bet you got questions? Come on, I'll show you around. Not like you can steal anything anymore." What followed was an educational afternoon. The sergeant walked him through the motor pool, explaining American maintenance philosophy with unguarded honesty. "See, the thing is," he said, "we design everything so any farm boy can fix it. Most of our guys never saw a vehicle engine before basic training, so we make it simple. Color-coded wires, standard bolts, everything labeled. We got manuals written for 6th grade reading levels. The idea is that if something breaks, anyone can fix it without calling in a specialist." The captured mechanic examined a disassembled Jeep engine. Every component was clearly marked. The maintenance manual contained detailed illustrations and step-by-step instructions that could be followed by someone with minimal mechanical knowledge. He asked, "How many of these do you produce?" The sergeant shrugged. "Hell, I don't know exact numbers, but thousands every week, I'd guess. They keep coming off the production lines faster than we can ship them out. We got so many Jeeps that if one breaks down, we usually just grab another one instead of fixing it immediately." Thousands every week. The number seemed impossible, yet the evidence was everywhere. This motor pool contained more vehicles than entire German divisions had possessed, and this was just one small American unit at a forward supply base. The sergeant continued the tour. Dodge trucks capable of hauling loads that would require 2 German vehicles. Half-track personnel carriers produced in quantities that made German equivalents seem like rarities. Tank transporters that could move armor without wearing out their tracks. The thing is, the sergeant explained, we learned from the last war. We build everything with common components. A bolt from a Jeep fits a truck, fits a half-track. Same with electrical parts, hydraulic systems, everything. Makes logistics simple. Instead of needing 1,000 different parts, we need maybe a couple hundred, and we produce them by the millions. This was the secret that German manufacturing had never fully grasped. Component commonality wasn't just about production efficiency. It was about creating a logistical ecosystem where any part could be used anywhere, any mechanic could service any vehicle, and the entire system reinforced itself. The journey from North Africa to American prison camps continued the education. At every stop, prisoners witnessed American production capacity operating at a scale that defied German preconceptions. The port at Norfolk, Virginia, processed thousands of tons of supplies daily with mechanical efficiency. Cranes loaded and unloaded cargo at speeds that would have required armies of workers in Hamburg. Trains carried prisoners across America in passenger coaches that would have been considered luxury in Germany. And everywhere there were vehicles. Cars filled parking lots outside factories. Trucks lined highways and convoys that stretched for miles. Military vehicles sat in depot yards by the thousands awaiting shipment to combat zones. At Camp Hearn, Texas, skilled mechanics volunteered for the motor pool. American camp commanders welcomed their expertise because the war effort demanded every available worker. For the next 2 years, German mechanics worked alongside American soldiers, maintaining the vehicles that kept the camp running. American mechanics approached vehicle maintenance with direct practicality. They weren't engineers striving for perfection. They were problem solvers focused on keeping equipment operational. When something broke, they fixed it quickly with whatever was available. When parts weren't available, they improvised. When a vehicle proved unrepairable, they cannibalized it for components and requested a replacement, which arrived within days rather than weeks. The captured mechanics observed American techniques closely. German mechanics were trained to maintain vehicles to factory specifications, requiring specialized tools and proper procedures. American mechanics were trained to keep things running by any means necessary. In peacetime conditions, German methods produced better results. In wartime chaos, American methods proved vastly more effective. The motor pool at Camp Hearn processed hundreds of vehicles monthly. Jeeps came in for routine maintenance, received service in hours rather than days, and returned to service. The efficiency came from parts abundance and component interchangeability. When a part needed replacement, the parts room had dozens in stock. When a tool was required, the tool room provided it immediately. When a vehicle was beyond repair, another one took its place. One German mechanic befriended an American soldier who had worked for Ford before the war. The American proved knowledgeable about the automotive sector. Before the war, he said, I worked on the assembly line at Willow Run. That's Ford's bomber plant outside Detroit, biggest factory in the world. We're building B-24 Liberators. Started production in '42, and by the time I got drafted last year, we were completing one bomber every hour. Every single hour, a complete four-engine heavy bomber rolled off that line. The arithmetic was staggering. 24 bombers per day, over 700 per month. The German asked, how is such production possible? The American explained, mass production principles. Mr. Ford figured out how to break down complex manufacturing into simple, repeatable steps. You don't need skilled craftsmen if every worker does one simple task repeatedly. A kid fresh off the farm can be trained in a week to install one type of bolt in one location. Do that with 1,000 workers and you get massive output. This was the fundamental difference. German production relied on skilled craftsmen building quality products in moderate quantities. American production relied on semi-skilled workers building adequate products in massive quantities. The American continued. Same thing with Jeeps. Willys Overland makes them, so does Ford. Both plants use identical specifications. A part from a Willys Jeep fits a Ford Jeep perfectly. They're completely interchangeable. That means if one plant gets bombed or has problems, the other keeps producing. Maintenance is simple because every mechanic learns one vehicle, not dozens of variants. The German mechanic thought about the Wehrmacht's vehicle inventory. Dozens of different truck types from different manufacturers, each with unique parts and maintenance requirements. Kubelwagons from Volkswagen, command cars from various sources, captured vehicles from across Europe, each requiring its own spare parts and knowledge base. German logistics were a nightmare of incompatible systems. American logistics were streamlined through uniformity. The Americans said, the real genius is that we designed for manufacturability from the start. When they put out the requirements for the Jeep back in 1940, they gave companies just 75 days to produce a prototype. American Bantam did it in 49 days. Then Willys and Ford refined the design for mass production. Everything had to be simple to manufacture, simple to maintain, and simple to repair. The captured mechanics had examined enough Jeeps to recognize this truth. The vehicle wasn't elegant. German engineers would have designed something more sophisticated. But sophistication impeded mass production, and mass production was winning the war. By summer of 1944, prisoners had heard rumors of Operation Overland, the Allied invasion of Normandy. When news arrived of the landing's success, many felt no surprise. The Allies had the manufacturing capacity to build an invasion fleet that would have taken Germany years to assemble. News filtered into the camps through American newspapers and radio broadcasts. They read accounts of the Normandy beaches where Allied forces had landed with thousands of vehicles in the first wave alone. Jeeps, trucks, tanks, amphibious vehicles all carried across the English Channel in purpose-built landing craft, themselves manufactured in the thousands. The scale of the operation defied comprehension. 6,000 ships, 11,000 aircraft, 150,000 men in the first wave. Within weeks, millions of Allied soldiers would be fighting in Europe, all supplied by a production base that created equipment faster than the Wehrmacht could destroy it. German prisoners reflected on their pre-war confidence in victory. That confidence had been based on assumptions about German technological superiority. Those assumptions proved incomplete. Germany had superior engineering in many areas. German tanks were heavily armored and better armed than most American equivalents. German aircraft were often more sophisticated. German small arms were excellent. But none of that mattered when America could produce 5 tanks for every one Germany built, 10 trucks for every German truck, 100 Jeeps for every Kubelwagen. In the motor pool one afternoon, prisoners watched American soldiers loading Jeeps onto transport trucks for shipment to the port. A young private drove each Jeep up the loading ramps with casual confidence. Dozens of vehicles loaded in less than an hour, all bound for Europe to replace losses and supply new units. One German mechanic realized that this single loading operation at one camp in Texas represented more vehicles than his entire division had possessed in North Africa. And this scene was being repeated at camps and depots across America every single day. The mathematics became inescapable. Germany had mobilized its economy for total war, stripping civilian production to support military manufacturing. Yet German military vehicle production in 1943 totaled less than 100,000 units of all types. America, maintaining a thriving civilian economy, produced over 2 million military vehicles the same year. The disparity wasn't just quantitative, it was qualitative. American vehicles were designed for wartime realities: ease of maintenance, interchangeable parts, simple operation, rugged reliability. German vehicles were engineered to specifications that made sense in peacetime, but proved impractical in sustained combat. In November 1944, news reached the camp of a German offensive in the Ardennes, what would become known as the Battle of the Bulge, Hitler's last gamble in the West. The offensive relied heavily on capturing American fuel supplies because Germany no longer had sufficient fuel to sustain armored operations. More troubling were reports of Operation Greif, Otto Skorzeny's commando operation using captured American equipment. German soldiers had been equipped with captured jeeps, American uniforms, and fake identification, tasked with infiltrating Allied lines to cause confusion and capture bridges. If even Skorzeny, Hitler's favorite commando, who had rescued Mussolini, was reduced to depending on captured American vehicles because German vehicles were insufficient, that revealed everything about the Wehrmacht's material situation. The operation failed. American military police quickly identified the German infiltrators through careful questioning about American culture and procedures. The Ardennes offensive itself ground to a halt, not primarily from American resistance, though that was fierce, but because German forces ran out of fuel. Panzer divisions abandoned their tanks when fuel trucks failed to arrive. Infantry divisions resorted to horse-drawn transport because motorized logistics had collapsed. By January 1945, the German attack had been contained and reversed. Spring of 1945 brought news of Germany's collapse. The Red Army closed on Berlin from the east. American and British forces crossed the Rhine and drove deep into Germany from the west. In the camp motor pool, German mechanics continued their work, maintaining vehicles for an army that had defeated their homeland. They felt no satisfaction in their work, but no shame either. Germany had lost not because its soldiers lacked courage or skill, but because it had challenged powers whose production capacity it could never match. One afternoon in April, an American soldier approached with news. Germany surrendered. War's over in Europe. The mechanics nodded. They had expected this for months. What happens to us now? You'll go home eventually, probably not immediately. Lots of logistics to work out, but you'll go home. One mechanic considered this. Home to a Germany that had been bombed into rubble, occupied by foreign armies, its cities destroyed by the same manufacturing might that had produced the Jeep he had examined years ago in the desert. The American asked, "You're a smart guy. Did you really think Germany could win?" The mechanic thought carefully about his answer. Before the war, yes, we believed German quality would overcome American quantity. We had seen American products before the war, and many were inferior to German equivalents. We assumed American military equipment would be the same, but it wasn't. He paused. When we examined that first Jeep in '42, we realized we had made a fundamental error. We had confused peacetime quality with wartime effectiveness. Your Jeep wasn't better engineered than our Kubelwagen in absolute terms. It was better designed for mass production and field conditions. In total war, that proved decisive. The American nodded. Yeah, we build adequate products quickly and in huge quantities. Exactly, the mechanic said. They stood in silence for a moment. Two mechanics from opposing sides, united by shared understanding of what had actually determined the war's outcome. The repatriation process began in late 1945. German prisoners boarded ships for the journey home. One mechanic arrived in Bremen, India in January 1946, processing through Allied control stations before being released. The city was ruins. Rubble stretched in every direction. But amid the destruction, he noticed something. American vehicles everywhere. Jeeps carrying Allied officers through the shattered streets, trucks delivering relief supplies, motor pools where German civilians worked alongside Allied soldiers. He approached one motor pool, introducing himself to the American captain in command. His English, learned during years of captivity, was serviceable. "Sir, I am a former Oberfeldwebel of the Afrika Korps, recently repatriated from Camp Heron, Texas. I am a trained vehicle mechanic with experience maintaining American equipment. Are you hiring civilian workers?" The captain examined his identification papers. "Says here you worked in our motor pool in Texas, that right?" "Yes, sir, 2 years." The captain made a note. "We need mechanics desperately. Most German mechanics either died in the war or are still in POW camps. You can start tomorrow. Pay is in occupation script, redeemable for rations and necessities." And so the former Afrika Korps mechanic found himself employed by the army he had fought against, maintaining the same vehicles he had examined as enemy equipment. The Allies needed mechanics. He needed work. The war was over. Life continued. Over the following months, he witnessed the beginning of Germany's reconstruction. American aid poured in, distributed with the same efficiency that had won the war. Food, medicine, construction materials all arrived in American trucks, coordinated by American planners who approached Germany's rebuilding systematically. He worked in the motor pool, training young Germans in American maintenance techniques. Many of his students were former Wehrmacht soldiers like himself, men who needed civilian skills in a Germany that would no longer have a military. He taught them what he had observed: simplicity over sophistication, functionality over perfection, results over theory. These were lessons learned from American vehicles, applicable to rebuilding German manufacturing. By 1947, he had been promoted to supervisor of the motor pool's German civilian staff. The American captain who commanded the facility treated him with respect, valuing his experience and organizational skills. One evening, the captain invited him to share a drink in his office. "I've been thinking about something. You've worked with both German and American vehicles extensively. If you were designing a vehicle for the new Germany, what would it look like?" He considered carefully. "I would adapt the American approach for European conditions. Smaller than a Jeep, more fuel efficient, but maintaining the same philosophy. Common parts, simple maintenance, designed for manufacturing rather than engineering awards. Europe has narrow roads and limited fuel, but we need the reliability of American design thinking." The captain nodded. "That's smart. Marshall Plan money will rebuild German manufacturing, and German engineers are already studying American methods. The future is American-style mass production adapted for local conditions." This proved prophetic. In the decades that followed, West German manufacturing adopted American production philosophy while maintaining German attention to quality. The result was an economic renaissance that transformed Germany from a devastated nation into an economic powerhouse. Companies like Volkswagen, which had produced the Kübelwagen during the war, evolved into global automotive giants by combining German engineering precision with American mass production techniques. The Volkswagen Beetle, which became one of history's best-selling automobiles, embodied this synthesis. It was simple, reliable, manufacturable in huge quantities, and affordable for average families. former Wehrmacht mechanics who had worked in American prison camp motor pools returned to Germany with knowledge that proved invaluable. They understood component standardization. They had witnessed efficient parts distribution systems. They had seen how simplified maintenance procedures increased vehicle availability. They had observed how designing for manufacturability rather than perfection enabled mass production. These insights, gained through years of maintaining American equipment, influenced German automotive design for decades. The German manufacturers that emerged from the ruins didn't try to recreate pre-war approaches. Instead, they synthesized German precision with American production efficiency. By the early 1950s, this hybrid approach was producing results. Volkswagen production ramped up from thousands of vehicles annually to hundreds of thousands. Mercedes-Benz adapted assembly line techniques while maintaining quality standards. BMW restructured its manufacturing to emphasize component commonality across model lines. The economic miracle of the 1950s and 1960s owed much to these changes. West Germany became an export powerhouse, selling vehicles globally that combined reliability with affordability. The synthesis of German and American approaches created products that neither nation's pre-war philosophy could have produced alone. U.S. Army historian Hugh M. Cole, who interviewed Wehrmacht generals after their surrender, documented their perspective. Cole reported that German military leaders admired the Jeep more than anything else in the formidable American arsenal. Not the B-17 bombers, not the Sherman tanks, not the artillery, the simple Jeep, because it represented the manufacturing philosophy that had actually won the war. General George C. Marshall himself called the Jeep America's greatest contribution to modern warfare. This wasn't hyperbole. The Jeep embodied principles that transformed not just military logistics, but post-war global manufacturing. Standardization, simplification, design for production, emphasis on reliability over sophistication. By November 1943, the U.S. Army had enough data on captured Kübelwagens to publish Technical Manual TM E9803, a complete guide to operating and maintaining German vehicles. The manual was published on June 6, 1944, D-Day, enabling American forces landing in France to utilize any Kübelwagen they captured. The Wehrmacht didn't need to publish an equivalent manual for the Jeep despite capturing thousands. They didn't need to. The Jeep was intuitive enough that any mechanic could figure it out. This contrast illustrated the fundamental difference in design philosophy. The Kübelwagen required a detailed manual translated into English for American mechanics to understand its sophisticated systems. The Jeep required no manual at all for German mechanics to operate and maintain it effectively. The reunions began in the 1960s. Former members of the Africa Corps who had been captured in Tunisia gathered to remember fallen comrades. At one such gathering in 1967, an impromptu discussion arose about the vehicles of the war. One former mechanic offered his perspective. The Kübelwagen was better engineered in many respects, lighter, more fuel-efficient, excellent for desert conditions, where its air-cooled engine gave advantages. But the Jeep was better designed for modern war. Four-wheel drive, simpler maintenance, common parts, and most importantly, producible in quantities we could never match. An old officer who had commanded a reconnaissance unit nodded. I remember capturing my first Jeep in '41. We thought it was crude compared to our vehicles. Took us months to realize that simplicity was actually elegant efficiency. By '43, every unit wanted captured Jeeps because they worked better under combat conditions. Another veteran added, the worst moment for me was realizing that America was producing more Jeeps in a week than Germany produced Kübelwagens in a year. That's when I knew we would lose. Not from any particular battle, but from simple mathematics. They could replace losses faster than we could inflict them. This was the consensus that emerged from such discussions. German soldiers had tremendous respect for the Kubelwagen as a vehicle, but they recognized that the Jeep and what it represented about American production capacity had been decisive, not through combat effectiveness alone, though it was effective, through what it revealed about the disparity in manufacturing capability between the combatants. The Wehrmacht's logistical situation had been dire throughout the war. By 1943, approximately 80% of German divisions relied on horse-drawn transport. The German army entered World War II with 514,000 horses and would eventually employ 2.75 million horses and mules during the war, with approximately 1.1 million horses in service at any given time. Over 2 million of these animals died during the conflict. In contrast, American divisions were completely motorized. Every American unit relied on trucks, not horses, for logistics. This created operational advantages that Wehrmacht commanders envied. American supply columns could move hundreds of kilometers in a day. German supply columns, limited by the walking speed of horses, averaged perhaps 30 kilometers daily in good conditions. When Wehrmacht generals examined the reasons for their defeat, they consistently pointed to material disparity rather than tactical or strategic failures. German soldiers fought with skill and courage. German officers made reasonable tactical decisions. But German industry couldn't produce enough equipment to sustain operations against enemies with overwhelming material superiority. The Jeep became the symbol of this disparity, because every German soldier who encountered one understood what it represented. Here was a vehicle so abundant that Americans treated it as disposable, so reliable that it required minimal maintenance, so simple that any soldier could operate and repair it, so effective that German units preferentially used captured Jeeps over their own vehicles whenever possible. In 1976, the United States Army began replacing the Jeep with the HMMWV, the Humvee. The Jeep had served for 35 years, an extraordinary lifespan for any military vehicle. Many remained in service with reserve units and Allied militaries for decades more. That same year, Volkswagen celebrated the 1 millionth Volkswagen Golf produced. The Golf, like the Beetle before it, embodied lessons from both German and American approaches. Precision engineering combined with mass production efficiency. The synthesis that had rebuilt Germany. By the 1980s, West Germany had become one of the world's leading economies. German automotive companies exported millions of vehicles annually. German manufacturing was synonymous with quality and reliability, but that quality was now paired with efficient production methods owing much to American influence. The final Africa Corps reunion took place in 1998. Fewer than 20 veterans attended, all in their 70s or 80s, survivors of a conflict that had ended more than half a century earlier. During the reunion, someone mentioned that a local museum had acquired a restored Willys MB Jeep. Most of them wanted to visit. They stood around the vehicle, these elderly men who had once been young soldiers in Africa, examining it with the eyes of mechanics and warriors who had come to respect it. One veteran reached out to touch the hood, his arthritic fingers tracing the familiar lines. "I captured one of these in 42. Used it for 3 months before I got wounded at El Alamein. Best vehicle I ever drove. Better than anything we had." Another nodded. "I examined one in Tunisia just before we surrendered. Couldn't believe how simple the design was. Realized then that we'd been approaching vehicle design all wrong. Too complicated, too difficult to produce and maintain." A third veteran added quietly, They made over 600,000 of them. We made 50,000 Kubelwagens. That ratio told you everything." They stood in silence for a moment. The Jeep sat before them, a museum piece now, its war long over. But for these veterans, it represented something more than a historical artifact. It was a symbol of the production capacity that had defeated them, the functional engineering that had proven effective, the abundance that had overwhelmed scarcity. "We never had vehicles like this," one finally said. "Not in the numbers, not with the reliability, not designed with the same philosophy. We built for perfection. They built for production." This was the lesson that Wehrmacht mechanics had absorbed examining captured Jeeps in the deserts of North Africa, in the mountains of Italy, in the fields of France. It was a lesson that shaped post-war Germany and influenced global manufacturing development. The Jeep had been more than a vehicle. It had been an education. Wehrmacht mechanics, humbled by defeat, had proven to be excellent students. They studied not just how to maintain American equipment, but why that equipment had been designed as it was, and what those design choices revealed about the manufacturing philosophy that had won the war. That knowledge, painful in its acquisition, became the foundation for Germany's reconstruction and eventual prosperity. The defeat taught humility. American equipment taught functional engineering. The combination produced a new German philosophy that served the nation far better than pre-war hubris. The story of Wehrmacht mechanics and the Jeep is a story of learning through defeat. Pride had told them that German engineering was superior, that quality would triumph over quantity, that sophistication would overcome simplicity. Reality taught them otherwise. American vehicles were not better engineered than German equivalents in most technical specifications, but they were better designed for modern warfare's realities, producible in massive quantities, maintainable by minimally trained personnel, built with common interchangeable parts, reliable under abuse. This functionality, multiplied by American manufacturing capacity, created overwhelming material superiority that no amount of German skill or courage could overcome. The Wehrmacht had excellent soldiers, capable officers, and sophisticated equipment, but it lacked the foundation necessary to sustain total war against enemies who could produce equipment faster than Germany could destroy it. The mechanics who maintained both German and American vehicles understood this through direct experience. They had seen both systems operate. They had worked with vehicles designed according to different philosophies. They knew which approach worked better under combat conditions. That knowledge informed their work rebuilding Germany. When they trained young mechanics, they emphasized lessons learned the hard way. When they consulted on manufacturing processes, they advocated for standardization and simplification. When they designed new products, they prioritized manufacturability and reliability over theoretical perfection. The engineers who rebuilt German automotive and machinery sectors had studied captured American equipment, worked in prison camp motor pools, and observed American manufacturing methods firsthand. They created a hybrid, German precision combined with American production efficiency. That hybrid proved extraordinarily successful. By the 1970s, West Germany had become a leading exporter of manufactured goods. Companies that had been bombed to rubble in 1945 were now competing globally. German cars, German machinery, German industrial equipment, all respected worldwide. The economic success validated lessons learned from defeat. Germany had abandoned the hubris that contributed to catastrophe and adopted a more effective approach informed by studying the victor's methods. The Jeep played a meaningful role in that transformation, not through some grand design or intention, but through direct experience. Every Wehrmacht mechanic who maintained a captured Jeep absorbed insights about American philosophy. Every officer who rode in a captured Jeep recognized its advantages over their own vehicles. Every soldier who witnessed the abundance of Allied vehicles understood what propaganda had tried to conceal. These experiences, shared by hundreds of thousands of German soldiers and prisoners, created widespread understanding that Germany's defeat was not primarily military, but material, not tactical, but industrial, not about courage or skill, but about production capacity and resource availability. This understanding shaped attitudes toward Reconstruction. German leaders and engineers looked to adapt American methods rather than restore pre-war practices that had proven inadequate. They embraced mass manufacturing rather than emphasizing small-scale craft production. They designed for manufacturability and reliability over theoretical perfection. The Wehrmacht mechanics who first encountered Jeeps in North African deserts could not imagine the long-term influence of that encounter. They were simply trying to understand an enemy vehicle, assess its capabilities, determine whether it could be used by their own forces. In doing so, they discovered truths about manufacturing capacity and engineering philosophy that would shape the rest of their lives and influence their nation's reconstruction. The last of those mechanics have passed away now. Their direct testimony is lost, but the lessons they learned remain embedded in manufacturing practices worldwide. Every vehicle designed for ease of manufacture owes something to the philosophy the Jeep embodied. Every standardized part reflects American influence on global standards. Every emphasis on reliability over sophistication echoes lessons from motor pools where Wehrmacht mechanics maintained captured American equipment. You see, there's something profound in this story that goes beyond just vehicles or even warfare. It's about how we approach problems. The Germans approached vehicle design the way master craftsmen approach their work, seeking perfection, optimal performance, engineering excellence. There's nobility in that approach. There's pride in creating something truly superior. But the Americans approached the problem differently. They asked, what do we actually need this to do? What conditions will it face? Who will operate it? How many do we need? And then they designed accordingly, not for perfection, but for effectiveness at scale. Neither approach is wrong in absolute terms. In peacetime, when you're building a small number of vehicles for specific purposes, the German approach makes perfect sense. You want the best possible machine. But in total war, when you need hundreds of thousands of vehicles operating across multiple continents in every climate and terrain imaginable, maintained by teenagers who were farmers 6 months ago, the American approach proves superior. The Wehrmacht mechanics learned this lesson in the most difficult way possible, through defeat. But they learned it thoroughly, and to their credit, they didn't reject it out of pride or nationalism. They absorbed it, studied it, and applied it to rebuilding their country. That's the real story here. Not just about a vehicle, but about the humility to learn from your enemies, about recognizing when your assumptions are wrong, about adapting and evolving, rather than clinging to ideas that reality has proven inadequate. In November 1942, when those mechanics opened the hood of that captured Jeep in the desert, they began a journey from confidence in their own superiority to understanding a different approach, from pride to humility, from theory to reality. That journey was painful. It came at tremendous cost, but it ultimately led somewhere valuable. The Germany that emerged from World War II was different from the Germany that entered it, not just politically, though that changed too, but philosophically, in how it approached manufacturing, engineering, design. The post-war German automotive industry didn't try to recreate the pre-war approach. It synthesized the best of German precision with the best of American practicality. That synthesis created some of the most successful companies in history. Volkswagen became the largest automaker in the world. Mercedes-Benz became synonymous with quality. BMW, Audi, Porsche all thrived by combining engineering excellence with manufacturing efficiency. The mechanics who examined that Jeep in 1942, who worked in American motor pools as prisoners of war, who returned to rebuild their country, they were the bridge between these two approaches. They carried knowledge gained through defeat back to a nation that needed to rebuild. And that knowledge, as much as Marshall Plan money or any other factor, helped create the German economic miracle. There's a broader lesson here, too, one that extends beyond Germany or even World War II. It's about how innovation happens. True innovation isn't just about having the best engineers or the most advanced technology. It's about understanding the problem you're actually trying to solve. The Jeep wasn't the most advanced vehicle of World War II. German engineers could point to dozens of ways it could have been improved. More power, better suspension, lighter weight, more sophisticated systems. All true. But the Jeep solved the actual problem, providing reliable transportation to military forces under combat conditions at a scale necessary to win a global war. German vehicles, for all their engineering excellence, didn't solve that problem as effectively. They were harder to produce, harder to maintain, less versatile in difficult terrain. They were, in a sense, answers to a different question than the one the war was actually asking. This happens all the time, in every field. Engineers and designers create solutions that are technically impressive, but don't quite match real-world needs. Entrepreneurs build products that are feature-rich, but too complicated for average users. Companies optimize for metrics that don't actually drive success. The American approach to the Jeep, simplify, standardize, make it producible, make it maintainable, that's a lesson that applies far beyond military vehicles. It applies to any situation where you need to deploy a solution at scale, operated by regular people under less than ideal conditions. The Wehrmacht mechanics understood this by 1943. They had seen enough. They had maintained enough captured equipment. They had witnessed enough American abundance. They knew. But the war continued for another 2 years because knowledge at the mechanic level doesn't change strategic reality when the disparity is that overwhelming. By the time Germany surrendered, American factories had produced not just those 640,000 Jeeps, but millions of other vehicles, trucks, tanks, aircraft, ships, all built with the same philosophy. Adequate performance, massive quantity, simple maintenance, common parts. The Soviet Union had adopted similar approaches, producing vehicles like the T-34 tank in staggering numbers. Not the most sophisticated tank, but effective, producible, and available in quantities that overwhelmed German panzers despite their technical superiority. Germany found itself fighting enemies on all sides who had all, independently, arrived at similar conclusions about wartime production. Quantity matters. Reliability matters. Manufacturability matters. Sometimes these things matter more than technical excellence. The world that emerged after 1945 was shaped by these lessons. The Cold War saw both superpowers emphasizing mass production of weapons systems. The global economy saw manufacturing becoming increasingly standardized. International standards emerged for everything from screw threads to electrical systems, making global supply chains possible. In this sense, the Jeep was more than just a vehicle. It was a symbol and a catalyst for a fundamental shift in how the industrial world approached manufacturing, from craft production to mass production, from uniqueness to standardization, from perfection to adequacy at scale. German mechanics working in American motor pools in Texas and later in occupied Germany were witnesses to this transformation and eventually participants in it. They saw both sides. They understood what had been lost, the pride of craftsmanship, the satisfaction of engineering excellence. But they also understood what had been gained, efficiency, abundance, accessibility. The synthesis they helped create in post-war Germany tried to preserve the best of both. German cars maintained high-quality standards, but adopted American production methods. They were engineered for reliability and manufacturability, not just for performance. They used standardized components across model lines. They were designed for ease of maintenance. This approach proved commercially successful precisely because it addressed real customer needs. People wanted cars that were well built, yes, but also affordable, reliable, and easy to service. The German automotive industry, informed by lessons learned from the Jeep and other American equipment, delivered exactly that. There's a certain irony in this. The Jeep, designed quickly in 1940 to meet an urgent military need, ended up influencing global manufacturing practices for decades. It wasn't intended to be revolutionary. It was intended to be adequate, producible, and reliable. But those qualities, in that context, proved revolutionary. The designers of the Jeep probably never imagined that Wehrmacht mechanics would study their creation so carefully, absorb its lessons so thoroughly, and carry those lessons back to Germany, where they would influence an entire industrial renaissance. But that's exactly what happened. History works that way sometimes. Small decisions, practical choices made under pressure, end up having consequences far beyond their immediate context. The decision to make the Jeep simple rather than sophisticated, to prioritize production over perfection, to design for the mechanic rather than the engineer. These decisions made sense in 1940 for purely practical reasons, but they encoded principles that proved valuable far beyond World War II. As we think about this story now, more than 80 years after that mechanic opened the hood of that captured Jeep in the North African desert, it's worth asking what lessons still apply. We live in a different world. Technology has advanced enormously. Manufacturing has become global. The specific techniques that made the Jeep revolutionary are now standard practice everywhere. But the underlying principle remains relevant. When you're designing something, anything, whether it's a product or a process or a system, you have to ask who will use it, under what conditions, at what scale, and what they actually need it to do. Engineering for theoretical perfection without considering these factors leads to solutions that don't actually solve problems. The Wehrmacht learned this lesson the hard way. They built excellent equipment that their economy couldn't produce in sufficient quantities, and their soldiers couldn't maintain under field conditions. All that excellence didn't matter when they were outnumbered 10-1 by adequate equipment that worked reliably. The mechanics who stood around that restored Jeep at the museum in 1998, elderly men reflecting on their youth, they understood this deeply. They had lived it. They had fought with sophisticated equipment against simple equipment and lost. They had rebuilt their country by applying lessons learned from that defeat. "We never had vehicles like this," one of them said. It was an admission, but not one made with bitterness, just a recognition of truth. They had fought for a nation that approached problems one way. They had been defeated by nations that approached problems differently. They had learned from that experience. They had applied those lessons, and ultimately, they had thrived. That's perhaps the most important lesson of all. Learning from defeat, from mistakes, from approaches different than your own. That's not weakness, it's wisdom. The Wehrmacht mechanics who examined American equipment with genuine curiosity, who worked in American motor pools with diligence, who took lessons from their former enemies and applied them to rebuilding their country, they demonstrated more wisdom than the generals and politicians who had led Germany into catastrophe. There's courage in that kind of learning. It takes courage to admit your assumptions were wrong, to recognize that others had better solutions to problems you thought you understood, to set aside pride and nationalism in favor of practical knowledge. The Jeep facilitated that learning because it was so clearly, obviously, undeniably effective. Wehrmacht mechanics couldn't dismiss it as propaganda or make excuses. They could examine it directly. They could test it. They could compare it to their own vehicles. The evidence was right there, bolts and all. And once they understood what made it effective, once they grasped the philosophy behind its design, they couldn't unknow that. Even if they had wanted to reject those lessons out of pride, the knowledge was there. American approaches worked. That was simply fact, demonstrated thousands of times over in motor pools and battlefields. So they learned, they adapted, they synthesized, and in doing so they helped create something valuable from defeat. The German automotive industry that emerged after the war was better than what existed before, precisely because it combined German precision with American practicality. That industry employed hundreds of thousands of people. It generated enormous wealth. It created products that improved lives globally. None of that would have happened, or at least not in the same way, without the lessons Wehrmacht mechanics learned from captured Jeeps. In the end, that simple vehicle, designed in 49 days by American Bantam and refined for production by Willys and Ford, built in staggering numbers by semi-skilled workers, maintained by farm boys turned soldiers, that vehicle taught lessons that helped reshape the post-war world. It taught that simplicity can be sophisticated, that adequacy at scale beats perfection in scarcity, that designing for the user beats designing for engineering awards, that standardization enables abundance, that reliability matters more than peak performance. These lessons, learned through bitter experience by German mechanics in 1942 and 1943, applied by German engineers in the 1950s and 1960s, remain relevant today. Not just in automotive manufacturing, though certainly there, but in any field where you're trying to create solutions that work at scale, in real conditions, for actual users. The Jeep's legacy isn't just the HMMWV that replaced it, or the civilian Jeep still on the road today. It's a way of thinking about design and manufacturing that influenced the entire industrial world. And a significant part of that influence came through Wehrmacht mechanics who examined it, maintained it, learned from it, and carried those lessons home. They admitted they had never had vehicles like it. In that admission was the beginning of wisdom. In that wisdom was the seed of renewal. And in that renewal, a better approach to manufacturing that served the world for decades to come. That's the real story of the Jeep and the Wehrmacht mechanics, not just about a war or a vehicle, but about learning, adaptation, and the unexpected paths by which knowledge spreads and transforms the world. If this story got you thinking about how innovation really happens and how defeat can teach more than victory, you might want to check out our other videos. The video is right there on your screen, and I'll see you there.